G'day guys and welcome back to my channel. Today this should be the last series for this series. Sorry, the last episode for this series. We should just change op amps, remove compensation capacitors and be done. Something I forgot to mention in one of the last videos was I did mention it in a short, but I don't think I mentioned it in an actual video. I've actually gone through this and tested all of the transistors. I don't just mean in diode mode on my multimeter. I actually got the Atlas DCA Pro and actually hooked it up to all the pins on all the transistors and tested them all, and I was able to get readings off of all of them. I do realize they're in circuit and some might be, well no they're not, they're all basically emitter follower sort of, or Darlingtons. So no, it was fine. I could test it. There are some base to emitter resistances, but yeah, I was able to work all that out between checking the base to emitter resistances with my multimeter, measuring diode drops, and using the Atlas DCA Pro 75. I tested all the transistors. All the transistors are good. So that is wonderful news. What else do I have to say? Right, so there's something else I have noticed on this board that I do want to just go over this quickly. So the Zener diodes that I replaced, these guys, they're marked BZY88 and then it says C3V6. So you can see it's a 3.6 volt Zener. There are other diodes on this board that say BZY88 C10. Now, I really can't be bothered getting, going to Google right now and looking them up. So I think what I'm going to do is I'm just going to look for one that doesn't go across the inputs to an op amp or something like that. Because if it is, I found one. Because if it goes across the inputs to an op amp and it's not a Zener and it's open in the other direction, I'll be injecting 40 volts into an op amp. And I'm taking them away out anyway, but the ones that test good I want to keep, right? So try not to fry them all. I want to know if these are Zeners or if they're just normal diodes. Either I've got my leads in my meter the wrong way, which I thought I did the other day, so I swapped them around, so now I'm confused. Unless this is a back to back with another diode. What? Sorry about that, guys. My phone just ran out of storage. I think I was in the middle of saying the word diode. Right, so that could just be back to back with another diode forming a clamp, or that could be a really low voltage drop Zener, or that's not supplying enough current for it to reach breakdown or avalanche mode, whatever sort of Zener it is. What I'm going to do, okay, and there's some other ones that are marked OA200. I've got a funny feeling, well that's the thing, right? The OA200s, I don't see any BZYs, so I'm thinking maybe they're just like small signal diodes. And these ones I replaced with 1N4 007s, there are also some originals on this board, the FMR 402s or whatever they were. Yeah, something like that. I think they might just be small signal diodes, but these BZY88 series, I don't know if they're, you know what, I'm just going to get a data sheet. I don't want to take any risks, and I really don't want to take any more stuff off the board because it's burnt and the traces keep lifting. So I'll just put my mobile hotspot on and go to the computer here. Whoops. So we've got OA200s, Now I can't see if there's any more markings on there, like, is it BZY, OA 200? No, it's just OA 200. So we've got BZY 88 C10s. Those are the ones I really want to know. BZY AA C10 diode. Oh, well, good thing. I was right. They are 10 volt Zener diodes. You know, I'm really, really glad that I went off my gut instinct there. Okay. It looks like the 10 volt Zeners are not measuring as 10 volt Zeners. Interesting. So, let's continue, because there's a lot of these 10 volt Zeners. They all got different voltages on them. They might be in series, in parallel with a resistor, but man, that means I'm gonna. You know what? I'm just gonna duck off the J-Car quickly. Let me just see if J-Car have 10 volt Zeners. Because what they're doing here, just for everyone that doesn't know, these aren't for deriving references. What they're doing is they're basically, some of the supply rails are taken from the 56 volt rail, which comes out transformer, goes through the full bridge rectifier into a cat banks, got a 1K resistor across that, and then that goes through some like resistor divider networks and into more caps like us, 2-stage RC filters, some are 1-stage, and then that goes to more dropper resistors and Zeners to create very noise-free, smooth, regulated voltage rails to power all the low voltage stuff in here, like op amps and stuff like that, right? So, yeah, I've had a further look at the board and reverse engineered it a little bit more, and that's why I got curious about these diodes. So, 10 volts, yes, 1N4740. Let me just have a quick look and see how many I've got. 1N4742, 46, 37, 45, fucking hell, 44. Is it looking good? Oh, 1N4740. Oh. 1, 2, 3, 4, 5 of them. How many are on here? Oh god. 1, 2, 3, 4, 5. So 10. Does this second board, I'll just put it back together. Okay, that's OA 200s and power diodes for all gate. Okay, so 10. I'm gonna need another 10 1N4740s. Oh, God. Alright, OA 200s. Let's see what OA 200 diodes are. Okay, general purpose. So, yep, it's exactly what I thought. So they just like small signal diodes, you know, basically like your 1N4148s. Actually, 1N4 and 4.8s are better than them. You know what? Given that all the diodes are seeming to test funny in these are glass packages painted black, but they were made by the same company. I think I'm going to change all them too. I don't need to buy any 1N4740s. I've got plenty of them. Where are my 20s? Right. So, wait, 1N4740 times 10, because I've already got what you call it, about 6 of them, so I only need to stock up on 10 for this. One moment, I'm just going to grab some diodes. Alright. What have we got in here? Okay, these loose ones are the expensive ones. I've got some cheap Chinese ones in there too, but I've kept them on a packet, and these are also the same ones. But anyway, I don't ever put Chinese components with my legit components. So how many of those do I have? 1, 2, 3, 4, and there's 2 on the other board, so I only need 6 1N4 and 4.8s. I'll just stand them up in there for now. Maybe that wasn't such a good idea. Just everything goes missing in here. Oh, get in there, man. I was trying to save time and it's taking me more time. Right, I'm gonna put these back away. I have a fucking, sorry, further, I was going to say I'm going to have a fucking good look over it now. I'm trying not to swear on camera. I've got to get out the habit of that too. Let's just have a good look over it quickly and make sure there's nothing else I need to pick up whilst I'm out. I did test all the resistors too. Not all these smaller ones. I've tested a few of them and they're in value. They're all fine. But I did test the bigger ones. I have current going through them and they bang on. That's why I haven't even replaced them with newer modern day ones. They're actually really nice. Although they may be wire wound. I think they are wire wound. Yeah, so you know what? I'll probably swap them out too actually. Because wire wound resistors have a lot of inductance to them, which is not something you want on a power supply. So I'll probably swap them out for some sort of film resistor. Probably just carbon film power resistors like that. Yeah. Alright, I'm going to go get on my bike and duck off to J car. What I wanted to do, what I was literally just coming in here to do, so 10 of them, yeah, alright, got everything. I was going, hey, I don't think I tested these big diodes. Coolies. Alright, I'm going to go off the J car. What I was going to do today, just for you guys, I'm confident on my work, but I was going to get a couple of clips across the anode and cathode on these and power this up and let you guys see the 5.1 volt references, because I know you only got to see the 3.6s and they were both at 3.606 or 3.606 and 3.609 or whatever. That bang on. I mean, like the accuracy of what the reference was before in this is ridiculous. Like one was around 3.3 and the other one was around 3.6. They're both 3.6 now, you know. And like I said, the temperature drift and everything, the accuracy of a TL301 versus a Xene is just orders of magnitude better. So yeah, I might even do a few other little mods to this. So I don't want to keep pulling these boards back apart. The thing is, I was just going to power it up and measure the those 5.1 volt regulators just to show you guys. It's okay. Worst comes to the worst, if the brass pins start to open up, I can always tighten them again. It's not the end of the world. One thing that I might do, and I'm not talking about capacitors like this, these are compensation capacitors that will be going across an op amp or across a transistor. I won't change the value to those because, you know, increasing those to try and get rid of noise is just going to fuck up the slew rate. It's basically going to turn the amplifiers into slow amplifiers, which we don't want to do. But in other areas where there are, like what I did on the front panel with the output capacitor, I put a 1 microfarad monolithic in parallel with 2 low ESR 100 microfarad caps. You know, like I may do some other stuff like that too. Like these drivers, you know, the driver stage from the reference is just this 4.7 microfarad. I might stick a 1 microfarad monolithic across that too, because that will really attenuate high frequency noise a lot, especially where that is in the circuit. So probably, let's just say I will do that. Actually, I'm running low on monos. Like I was saying the other day, JCar's running out. These are better anyway. Even lower ESR. These are 1 microfarad MKTs, 100 volt. I'll add them. So that's going in it, and I'm going to go after JCar. Like I said, I was missing a few Zenas. I'm going to add a couple more to my list that I'm missing, but I'll leave this video here. Well, I'm not leaving the video here, I'm just stopping it because I've spliced my videos together. I'm going to duck off to JCar now. I'm going to go grab some parts and we'll come back and we'll get this finished today. There we go, guys. The references are in heat shrink now, so they can't short on anything. And when I put this in here, the references will just sit here and here, and I'll just put some contact adhesive down there and glue the heat shrink down to there, so they won't be moving around anywhere and they're well isolated. And you got access to the pots should calibration be needed. And one other thing I want to point out is the only pots that I found on this unit are these two and these two so far for calibration. So now we also have calibration on the references too. So more points of calibration is always good too. Alright, I'm back. Can't even remember where I paused the video. So I hope no one's too unhappy about this. You may notice some Zener diodes have been fitted. I just recorded a video, and when I thought about it, I had to just delete the video because I couldn't upload it. I lost my bloody mind. I was swearing, doing stupid shit because I was angry and rushing. So just to cut a long story short, I went to JCar to get Zenas. Didn't realise until I came back and started fitting them that they gave me the wrong ones. And the reason that this pissed me off so much is because when I rocked up there, I told them what I needed. I needed 1N4728s, 1N4733s, 1N4740s, and one other one, I can't remember. Anyways, the guy gets them. Excuse me. The guy gets them, and I look at the 5.1 volt ones, the 4733s, and literally 95% of the 10 of them, so like, I don't know, 8 or 9 of them, were 1N4739s. So I grabbed the box. It's It's behind the counter. Like, they know me in there pretty well. So the guy passed me the box, and there was a packet in there that actually had the, what do you call it, like a brand new lot of actual 4733s. And then in the bottom of the box, there was all these loose ones. So I took my time and I grabbed the 1N4739 box and looked inside that, and that had 1N4739s and 1N4740s in it, which incidentally I needed some. So I took both the boxes plus the proper boxes that the diodes were supposed to be in, so the 4740s and the 4739s, over to the microscope, and I sorted them all out for them because they don't know anything. I asked them, the guy goes, how do you even know that it's wrong? I go, it's written on the diode, you can read it. Like, I didn't say it sarcastically like that, but I'll tell you what, I was thinking it. And he's like, man, we don't get taught any of this. I go, what do you mean? He goes, we just get a 2-minute rundown. I go, what do you mean a 2-minute rundown? Like, you couldn't, I couldn't explain to you the difference between a single gang, a double gang, a 3 gang, a 4 gang, single position, dual throw, single position, single throw, dual position, dual throw. I couldn't, you get what I'm getting at, I couldn't explain switches in 2 minutes. How on earth do you run an entire store on a 2-minute rundown? That boggled my mind. Anyway, so with this knowledge, I realised that I'm in worse off hands than what I already thought I was when I go there. I already given up on ordering stuff pick up to go and get it, because I'd order all the transistors and Zeniths and stuff like that, go pick it up, come home and realise that the transistors were all wrong. Some were right and there'd be just random ones in there, and the Zeniths would be wrong. Anyway, cut a long story short, I went over the microscope and I sorted out the 5.1s that had the 39s with the 33s, and the 39s that had the 40s in it. I took my 1N4740s out, put them on the counter. I sorted the rest out, gave him his boxes back, put my 10 5.1s, the 33s on the counter. And whilst I did that, the guy was supposed to be sorting out the other 2 ones that I wanted. And I thought, like, after showing him how to read it, that, surely how could he screw it up, right? So I come back home and I start doing this. And this is where I'm really started to get pissed off, because I already rode my push bike there multiple times the last few days. That's my fault for missing things that I was meant to get. But anyway, that was getting annoying. And then I come back and I'm making this video and I'm installing the diodes. And then I realized that half my 4740s are 4739s. And I started to lose it, because this, you got to understand, I took the 39s, I put them in the 39 box, put the box on the table for him to put the box back in the, what do you call it, component drawer on the wall. And somehow he's gone and taken 10 of them out and put them on the counter. I didn't even want any 39s. I didn't realise this until I come home, that one of the diodes that I wanted, so I wanted 3.3s, 5.1s, 10s, and let me go look at my list. I've thrown my list out. Damn it. Wait, maybe this is it. Hold on. I think I've got it. Oh, okay. I wanted 1N4728s, 1N4729s, 1N4733s, and 1N4740s. And if anyone thinks I'm making this up, there you go. You probably saw me writing this the other day anyway. I've added a couple other things on, but anyway. And And as you know, the tracks underneath these resistors are absolutely baked and peeling off the board, right? Which is where all these Zenas are, incidentally. So I install them all, and then I spot on this Zena here, 39 on the side of it. And I'm like, wait, what? I just remember this. I've got 28s, 29s, 33s, and 40s. No 39s. And the 39s I'd put in the 39 box and given back to him to put away. I was like, what the fuck? Like, the guy's literally gone and, you know, like I said, taken them out, the box I didn't even ask for, and put the ones I put on the counter away. I'm like, what on earth? I start looking through them, and it's like a mix. There's 39s and 40s. So I don't know what he did, because if he took my pile off the table and put them away and took all the 39s out the 39 box, I'd only have 39s. So I'm baffled what the guy did, because I had a mixture of 39s and 40s. Lucky for me, I already had 5 40s left in my own drawer. So I was able, when I got back and installed them all and then had to take half of them out, I ended up still having 10 47 40s in total left. I now have only 1 left and have to go and buy more again. I should have had 5 left after this, but anyway. And now I have a whole bunch of 39s that I didn't need. Anyways, that gave me absolute shits, and I was swearing over that. I kept knocking over my references, so that's why they bent over. I just left them bent over in the end, because if I keep straightening them, bending them, I'm going to weaken them, so I might as well just leave them bent and straighten them afterwards. Yes, I know I need a circuit board holder. Anyway, so that was happening. You know, and as I'm taking them out and putting them back in, like, I already had to make up traces out of solder and bits of wire in the first place. So you can imagine how annoying after you've bent over pins to make traces up and then find out they're the wrong components and have to take them all back out again. Like, I had to tear this to shreds, literally. I don't know if you can see on camera, but you can probably tell that pretty much all the traces there I've had to remake. And whilst, yes, it is nice and pretty and neat, I haven't even cleaned up all the burnt stuff on the flux yet. That took me time. So I was swearing at that, I was swearing at the diodes. And then my mate came over when I had just started work, and I was saying on the camera, I was like, I'm just going to get this done and I'm going to go, because this guy wants me to go and fix his son's motorbike. It's been sitting for a while, it's got stale fuel in it. He doesn't know why it doesn't start, I do, I've got to clean the carby out. But anyway, so I'm saying on camera, like, you know, this is only going to take me 15 minutes and then I'm going to go do this bike. And I'm sitting here losing my mind over this. Then he rocks up and I'm like, as you can imagine, I'm losing it more. I've probably said the F word about 20 times by now and started to, you know, put things down fairly hard, and I was getting pissed. So then I tell him, I'm like, can we just like make it tomorrow or later? I explained what was going on. He's my mate, it's all good, he's understanding. So I come back and I'm like, all right, I'm gonna get this done now. I live next door to houses. Why am I pointing this out? No sooner than I sit down and I start working, one of my bloody, you know, I'm just going to say the word, junky neighbours knocks on my door. Oh, excuse me, would you be able to lend me a couple of dollars to go and buy some sugar and some coffee? And the answer is always no, because I'm not going to pay for your food so you can stick a needle in your arm. That's literally why they broke. So yeah, oh man, everything was pissing me off. And when I realized like how long I'd been getting annoyed for. Oh, and the other thing was, I was already going over in the video the fact that every time I've gone to Jayco in the last couple of months, I open a drawer to get, say, 100 nanofarad disc ceramics, and the drawer's empty. And then, I can't remember when it was, as of a couple of weeks ago, I went in there, opened the drawer, it's no longer empty, but it's now got 100 nanofarad monolithics in the disc ceramic tool. So I've advised them of that. And also every time I've gone to get 105, 1 microfarad monolithics, there's been none. Keep telling them and they're like, yeah, we'll get someone to look at inventory, it will be sorted out in 2 weeks. They said the exact same thing again today. This has been going on for 2 months. For 2 months I've been trying to buy 0.1s and 1s in monolithic and disc, right? And I have not been able to buy any. That's, truth be told, that's why I bought extra 1 microfarad MKTs, because I needed 1 microfarad monolithics. They didn't have them, so I've bought these. They are better anyway, but they're also bigger, so in some applications it's not, you know. Anyways, when I watched the video back, I thought, man, the whole video is just like, with me like getting angry and swearing and complaining about Jaycar. I thought, man, I can't upload this. This is not professional, so I just deleted the video. I'm sorry about that, guys, but I've probably already bored people complaining just now in the last, how long's it been? 13 minutes, I'm sorry. But I just wanted to be honest and explain to everyone why I have started doing work and it wasn't on camera. I just couldn't put that footage on the internet. I went, settled myself down, had something to eat. I've come back and I'm going to continue now. Now, I'm going to have to pause the video because my soldering gun's blocked up. One of the other things that happened whilst I was getting pissed off in the video was the first 39 diode 4739 that should have been a 4740 that I spotted was that one right there. When I went to desolder it, I went to desolder this one. I mean, I desoldered this, but I went to pull this one out and I couldn't work out. I was impatient, you know, I was pissed. So I just yanked it and I snapped the lead. And then I got my desoldering gun, not thinking, and sucked the pin up and blocked the nozzle. So, yeah, you could say there was multiple reasons why I just decided not to upload that video. Alright. This filter's getting a bit blocked. Sorry about that. I'm not going to lie, I'm still in a slightly agitated mood now because I've just been thinking about everything again that happened today and it's annoyed me. And you got to understand, most of the time I ride my push bike there. It's a couple of suburbs away. So it's... Sorry, my desoldering gun's missing the vacuum. So it gets annoying, you know? Going backwards and forwards all the time just to get screwed over. Alright, that's better. So without further ado, I'm just going to get on with it. So all the 10 volt Zenas I've replaced, as you can see. All the traces that were buggered I have fixed up. Got these 4148s. I'm going to replace these, what are they called? OA200 diodes with. So without further ado, let's remove them. I feel like my desoldering gun's still not right. Yeah, what? Oh no. Alright, I'm I'm gonna have to pause the video. This has lost all suction from the actual pump. I'll be back. I'll work this out. Alright, we're actually perfectly fine. It was just, how do I explain this? There's 2 filters in it, and one of them was blocked up with flux residue because of all the flux on this old school board. I've just replaced it. What diode was I taking out? That one. Yeah, it sounds a lot better. I thought I could tell the pitch was going off on it, but I cleaned the other filter out just before, so I was like, nah, it must just be me. No, it was. I've done it again. I did this earlier too. I forgot to mark half the diodes before I took them out. We've only got 1, 2. Oh no. Oh no. No. Don't tell me. I might have made a big mistake, guys. I'm sure that there was 6 OA200s, and I can only see 4 here, which has me thinking that when I took the Zenas out and changed the Zenas, that 2 of them were OA200s. No. Okay, now I'm really confused. I really remember counting 6 OA200s. I'm only saying 1, 2, 3, 4. Maybe I counted 2 of the Zenas without reading them properly as the OA200s when I was looking at it before. That's the only thing I can think of. Really. Look, if I have replaced a 10 volt Zena with a 1N4148 by accident, it's not going to do anything too bad. All that's going to happen is when I turn it on, the resistor that powers the Zena might burn up, and it's not going to work because it's going to have a 0.6 volt supply or reference or whatever it's doing instead of a 10 volt one, you know. So it won't be the end of the world. I'll notice it straight away and be able to fix it. But yeah, let's hope not. What? I desolder. You know, it's funny, when I was desoldering that, I was looking at the pins and I was thinking that they were really thick. Yeah, they are thick because they were the 1 watt resistors or 3/4 watt resistors. Wait, that looks like something I've soldered. Yeah, that's a Zena. Oh, they're below the resistors. Okay. silly moment. I guess I got slightly confused because they're next to the resistors, and when I turn the board over, I've inverted the position of them. My brain obviously didn't click. I just realised I'm doing it again, my head's in the way. Hold on. Move this up. I'll have a look at where my phone's sitting in a sec. Oh, okay. Not too bad. Right. That should be the correct diodes. And tell me what? How the hell has that got solder on it? Alright. Now there we are. I'm still a bit stressed from earlier on. I think it's starting to show in my work. Alright. I was going to go do something quickly. I'll pause the video. I'll be back in a moment. Alright. I'm going to duck out in a minute, but just quickly, I just pulled the diodes through and splayed the legs out. I'm just going to solder these in. And guess what? You know how I was saying that I counted 6 OA200s? I was correct. The other 2 are on the other board. I just spotted them. So that's good because it means I definitely haven't put like the wrong diode in the wrong spot or something. Because that was my fear. But when I looked at all the other diodes, I didn't see any there, so it didn't really math out. Alright. Okay, so that's all the diodes that I'm going to replace on this board. Replaced. I think I'll still leave those references bent over because I've still got to get the op amps out too. let's get the two OA 200s out here and here and replace them with some 4148s. See how it doesn't ruin the traces where it's not burnt? Everything's fine. And yes, if he's... fuck, I've done it again. I was just going to say if you can tell I'm rushing, because I'm in a hurry. You know what I've just realised? I didn't mark those diodes. Oh my goodness. Okay, so they're clamping diodes for the op amp. You know what? I'm just going to have to pause the video. I'm not going to take any risks and just go back and watch it and work out what I did. That's what I get for rushing, I guess. Be back soon. Alright. I am back at the workbench. So I have taken notes. Obviously I don't need 10 to 25 of each of these values for this. It's just because I don't have them in stock and they're quite common values. I've got 0.22s and 0.1s and 2.2 ohms and yeah. So anyways, 10 watts, 5 watts. I just don't happen to have the ones I want. So anyway, let me go over a couple of things. So I'm going to pick up 10 to 25.47 ohm at 5 watt. So they look like these, but the 0.47 ohm. There's going to be 4 of them. They're going to replace these 4. That'll get the inductance down on the emitter resistors. Then the 1 ohm shunt resistors, same thing. They're 3 watt wire wound resistors. I'm going to change them to 5 watt carbon film. So that will get, you know, the inductance down even more. Also, if they even got slightly warm, these ones will get even less warm. Although actually I might have to do some calculations on that, because I don't know what the Tempco is. I'd imagine it would be pretty bad on the wire wound resistor, but let's just do a quick test. I know this is only rudimentary, but 1 ohm. I don't know if you guys can see the meter. Yeah. 1 ohm, 1.1 ohm. Oh wow. Yeah, okay, that changes a lot. Holy cow. I don't think carbon film resistors are that bad. I'm just going to grab one as close as I can get to that. Let's see. I actually have like just one, or at least something that's quite close. So I know I should have paused the video, I just thought that it would be right here and it would only take a second to get it. I got 2.79. Let's at least give that a bell. Alright, 2.7 ohms. It changes a bit, but it changes a lot less. And I mean, like, that's me cooking at 440 degrees. Oh, it's not even hot. 440 degrees. The other resistor, I just waved it across a couple of seconds and it went up. Okay, so yeah, that's going to give me better Tempco, less inductance. So yeah, that's a no-brainer. I'll get them tomorrow. Gives me another reason to go for a ride to Jaycar because I'm trying to get fit again. I always get into these habits of not riding. I ride a bike everywhere to keep fit, and I get into the habit of not riding for a few weeks, and then I'll start feeling unfit, and then I need to come up with reasons to get on the bike and go for a ride. I usually go for a few rides at Jaycar or somewhere, and then after that I'm feeling good again, and then I start doing like foreshore trails and stuff like that. But yeah. Anyways, before I get lost just wafting on again, let's put the last two 4148 diodes in this board. I have to play the video back to work out which way around the diodes went because I forgot to mark them when I took them out. I don't know why, but I've got a bad habit of doing that. I think I just got used to working on newer boards where everything's, got like a marking on the board. And yeah, it's not a good habit to get into. I can tell you that. Soldering iron's gone to sleep. Nothing new there. What I want to do now is basically, before I do the op amps, I want to do a bit of a test on it. I might stick those capacitors on whilst I'm at it, but what was I just looking at? I didn't like this. Okay, the capacitor leg was showing through the solder. Didn't like it. Right, so I'm going to put these diodes in, and then I'm going to put that 1 microfarad MKT, or two 1 microfarad MKT capacitors across those 4.7s. Excuse me, I'm just tracing something out just because I'm a curious person. Yeah, just as I thought. Yeah, these reference, or the Zenas don't inherently, none of these capacitors are like exactly across it, so it is a good thing I added the 4.7 mic to the regulators, otherwise they could have been unstable. I just wanted to make sure that there was a point in doing that. So on the bottom of the board where these two 4.7 mic electrolytic capacitors are, which is there and there, I want to add two of these. Alright, they're not going to fit, so I'll just leave them there and get two new ones. Right. Now I'll go over the second ones, more clearance. Yeah, that's where I'm going to put it. The only places I'm adding capacitance that wasn't already there is in places where it's not going to slow down the transient response time of the power supply. So for example, these compensation capacitors that are 103, you know, if I put say 100 nanos in there, because they're only compensation capacitors, they will slow stuff down. But filter capacitors are a different story. We can always improve that to a degree, sort of like when I upsized the input capacitors from 2200 microfarad to 4700. I still had to check the data sheet for the diodes to make sure that the peak inrush current of those diodes could handle what I wanted to give them. Otherwise, I would have had to have put, you know, better diodes in there. One thing I have learned in all the years of building power supplies, this is actually quite interesting because it's something you wouldn't think that has an effect on the regulation part of the circuitry, considering it's usually op amps or comparators and voltage references, and even if it's just transistors acting as comparators. But one thing I've noted in a lot of different power supplies that I've worked on or built myself is that with the diode bridge that you use to rectify the input, the less loss on the diode bridge, like the smaller the volt drop on it, the better the regulation. I've noticed that when under load, like a decent load, and there's more volt drop on that, the full bridge rectifier, the diode bridge, I have found that as that voltage drop occurs on the diode bridge, it basically it presents some of itself on the output as regulation error, and you end up having to do more stuff with offset and error sensing and stuff like that to account for it, you know, which is more circuitry. So I've found, for example, when I build a 5 amp power supply, if I use a 25 amp diode bridge as opposed to say a 10 amp one, it actually gives a noticeable difference in regulation performance. And the reason I'm pointing that out, actually, I don't want to move them yet. The reason I'm pointing that out is because so far every power supply I've pulled apart and looked inside has just had basically diodes that are just on the edge of being enough. You know, this power supply doesn't. For 1 amp, it's fine. It's got 6 amp diodes in it. They are in free air, and I don't think you can really mount them to anything anyway, so I don't know. It does say continuous current on the data sheet, but anyways, you know, there's two bridges, like, so there's two 6 amp bridges. So yeah, this one's alright, but the ones I pull apart these days to work on, new ones, no, not that good. Let's move that just ever so slightly so it's not shorting on anything. Alright, let's put these boards together. This should be the second last time that I put this together and pull it back apart again, because the only bit of work I've got to do now, providing all these new Zenas are working correctly, which is what we're going to test now, is the op amps. And let's face it, that's pretty simple. I mean, all of this is simple. It's only a power supply, but whoops. Oh, I don't want to knock the pot. That's alright. I can check the references later. Obviously, I will be double checking all the references and everything when this is actually working properly. Then I'll go over and calibrate everything and make sure it's bang on. So that's what I mean about these are just going to sit out, and then I'll just put some contacts adhesive on the bottom of them and sit them on the bottom of the chassis, and they're nice and isolated and they can't short on anything. I do realise that like this I can't get to the bottom board to test the two diodes. Oh, actually, you know what? I've got my references on the bottom board, which I know work, and the only other diodes I changed to 1 4/4/8 that I put in there. So all the Zenas I change are on this top board. So actually I can test all the work that I've done now. So that's everything hooked back up again. Let me just bring you guys into view. Just going to do one more visual sanity check on all of the Zenas, or actually all of the diodes that I've changed. Looks good to me. I'm quite happy with that. Alright, let's turn it on. No smoke, that's always a good thing. Are our references still working? Oops. I was on the wrong pins, guys. Say 3.606, look at that. Your beauty. Alright, let's go check all these Zenas, eh? Without shorting anything else. Beautiful, 10 volts. 10 volts on that Zena. 10 volts on that one. Uh-oh. Uh-oh. That's interesting. This one's got 3.239 volts on it. And they're both 10 volt Zenas. That is very interesting. Let's keep testing. That's got 10. That's got 10. 10. 10. 10. 10. So these ones that are in the middle, they're not right. They're definitely in the right way. That is quite interesting. What could possibly be causing that? I guess it could be, I guess it could be that those particular Zenas are powering an op amp that's short or something like that, you know? The Zenith's dropped through a resistor and then op amp runs off that, so if it was shorted it would pull the voltage down. I mean, that does make sense. I'm just changing the voltage on the front panel. I'm looking at my multimeter, and all of a sudden that makes voltage. What about the other channel? Auto tracking independent. Oh, what? I went to 10 for a second. You know, I think that's actually working. I think that's part of the regulation circuit. You see how that pops up to 10 under certain circumstances? Let's see what this thing's doing. We haven't actually had a look at what it's actually doing on the outputs since I have started. So I'll turn everything down, put it in independent mode. I'm looking at the first channel, the one that was already working first. That's the voltage turned down. Let's see, what have we got? That's interesting. That's the correct voltage now. And that's really responsive. That's working perfect. I guess the reference was off, so that kind of explains why it was off. Wait, is the panel meter working too? Because this panel meter had offset on it. Oh, wow. Yeah, the panel meter is almost working perfectly. Goes all the way up to 30. Hold on, let me just set an arbitrary voltage. I'm just setting it at 15 volts. Let's see what the meter says. 14.68. The panel meter is bloody working now. I just need to slightly calibrate it, but my panel meter is bang on 15, reading 15. All right, I'm going to set it to exactly 25 volts. Let's see what it says. Yeah, the panel meter is working. Well, look at that. Okay, let's see what the other channel is doing. Okay, that's turned down all the way and it's still got a voltage present that shouldn't be there. Winding it up all the way. Okay, so it still gets carried away. All good. The panel meter is working on this one now too. Wow, so a lot of things that weren't working before are working already now. I'll just show you guys. So remember the panel meter on this one showed like half the voltage it was at. It wouldn't go all the way up. Yeah. Now, it's not perfectly accurate, it's only a panel meter, but yes, it's working perfect now. And that zero offset's not there anymore. Same with this one. Remember it was doing that thing where it kicked back before? It's not doing that now, it's just trying to go over because the voltage goes up too high. So that's wonderful news. We're making good progress with this. Because this video is getting really long, I think I'm going to leave it there. All I've got left to do is the op amps. So, oh yeah, how hot are these resistors running? Oh wow, they're still hot. Man, I can't believe that they were using smaller resistors than what I've got in there, because, wow, that's hot. Like, really hot. I just can't believe that. And the 1K resistors that they were using, fuck, that's hot. They were using 3 watt resistors, running them at 3.3 watts. I mean, that's all hot as it is. Anyway, I'm really impressed. Couldn't ask for more, really, for what I've done. I haven't changed the op amps yet, and that's obviously is the bulk of the problem. So I think I'll end this video now. If I end up doing the op amps tonight, it will be a separate video, but then that will obviously be the last part. It'll be changing op amps and doing a little bit of calibration on the thing, and yeah, that will be this supply up and running finally, and then we can use this and the other supplies I've got to fix that Yamaha mixer amplifier that I'm in the process of rebuilding. So good things are happening. Plus I also have another dual tracking supply that I've bought, a brand new one that's about to arrive soon. So yeah, lots of good things are happening. Happening, whatever. Alright guys, I'll see you in the next one. You know what? Before I do, let's just turn this off. Take this edge connect off completely straight so we don't short any pins, because I've already done that. And carefully take this board out. Again, take this off straight. Let's do this. Let's get Jaycar catalogue, because it fits in there. So that will be that way. Where are my references? Oh, right, across here, across the holes, right. Let's just because you guys have seen the top references are 3.6 volts. So I want to show you guys that, because I haven't tested them myself, to be honest. Yeah, I'm sure they're working. Power up. You reckon these are going to be 5.1? Oh, 5.076. 5.1. I'll see if I can just ever so slightly trim that. Oops, I went the wrong way. I'm only going a very little bit at a time, obviously, because it's in circuit. $5.2. Oh, 5.164. I think I just went too far. I really wish I had put the 10k resistor in on the top and just used the pot for the bottom. It would have been a lot better, but it's alright. We will get it. 5.086. We'll get it. Even if I have to go backwards and forwards a couple of times and then eventually I get on it, it's alright. 5.173. I'm sure it's going to be over 5.2. Wait, what? Point wrong way. Thank God all the others are bang on and it's just the one. 5.008. If I can just get this up just a smidgen. Please don't be too far. Oh, close. 5.151. What's the other one at? 5. Fuck, that's exactly bang on. Alright, alright. You know what? I'm going to use a different tool because I was using this the other day and it was helping me. Really? Damn it. Come on. You can do it. I think I might just hook up some BOGO pins. Yeah, alright, this is starting to get too awkward. 1 second. Alright, that's going to be a lot easier for me, isn't it? That was a lot bloody easier, let me tell you. I'm happy. 5.1, 5.1. Alright. Well, I'm going to end that video here. And like I said, if I do more work tonight and I do the op amps tonight, then I know I've got to be really gentle with those because they're wrapped in heat shrink. It's not too tight around the pots for the reason I don't want the tension of it moving the pots, especially over time. But still got to be careful because if I squish it, I could knock the reference voltage off a little bit. Anyways, as I was saying, if I do the op amps tonight, that'll be obviously a separate video, and if all goes well, the last video. So thanks for watching, and I'll see you all in the next one. See ya.